In 1948, a man named Charles Elmer Doolin created the first Cheetos in a small kitchen in Texas. What began as an experiment has evolved into a global phenomenon with billions of bags consumed annually. The humble cornmeal-based snack has become one of the most recognizable food products on Earth. But the Cheetos you eat today are made using technology that would astonish their inventor. Industrial extruders operating between 100 and 200 degrees Celsius create the perfect puff through a process that's both art and science. In this video, we'll reveal every step of the 19-minute journey from corn kernel to cheese-covered snack. The creation of a Cheeto starts long before it reaches the factory floor. The journey begins with the careful selection of specific corn varieties grown in designated agricultural regions across the United States and South America. These corn varieties aren't the same as what you might find in grocery stores or on dinner tables. They contain unique genetic traits that make them particularly suitable for snack production. What separates an ideal Cheeto corn from other varieties? The answer lies in its starch composition. Manufacturers specifically look for corn with a precise ratio of amylose to amylopectin, the two types of starch molecules found in corn. This ratio directly affects how the cornmeal will behave during the extrusion process. Corn with too much amylose won't expand properly, resulting in dense, hard snacks. Conversely, corn with excessive amylopectin creates an overly fragile product that crumbles too easily. The selected corn arrives at processing facilities in massive quantities, often by the truckload. Before acceptance, each batch undergoes a series of rigorous tests. Laboratory technicians analyze samples for moisture content, which must fall within a narrow range of 12 to 14%. They also evaluate the corn for mycotoxins, pest damage, and foreign material. Any batch failing to meet these strict parameters is rejected, as even minor deviations could affect the quality of millions of Cheetos. Once the corn passes initial inspection, it moves to the milling stage. The process begins with cleaning systems that use air currents, screens, and magnets to remove any remaining debris, stones, or metal fragments. The cleaned corn kernels then pass through a series of grinding machines that progressively break them down into smaller particles. This multi-stage grinding is critical for achieving the specific particle size distribution required for Cheetos production. The first grinding stage removes the outer hull and germ of the kernel, leaving primarily the starchy endosperm. Subsequent grinding stages reduce the endosperm into cornmeal with precisely controlled particle sizes. This particle size distribution is carefully monitored throughout the milling process, typically ranging from 150 to 850 microns. The reason for this precision is that particle size directly influences water absorption during mixing, which in turn affects the expansion properties during extrusion. After milling, the cornmeal passes through additional cleaning equipment to remove any impurities that might have been introduced during the grinding process. High-sensitivity metal detectors scan the material, capable of detecting metal fragments as small as 0.5 millimeters. Optical sorters using high-resolution cameras identify and remove discolored particles or any remaining hull fragments that could create inconsistencies in the final product. The cleaned cornmeal is transferred to climate-controlled storage silos where temperature and humidity are maintained at constant levels. These silos are equipped with monitoring systems that continuously track conditions. The temperature is typically kept between 15 to 18 degrees Celsius, while relative humidity is controlled to prevent moisture absorption that would alter the carefully established moisture content of the cornmeal. These storage conditions are not arbitrary. They've been determined through decades of research to provide optimal stability for the raw material. The silos also feature specialized mixing systems that prevent the cornmeal from settling or compacting. This ensures uniformity throughout the stored material, as variations in density would create inconsistencies in the production process. The cornmeal typically remains in these silos for 48 hours to allow its properties to stabilize before being transported to the production line. What appears to be a simple ingredient actually requires extraordinary precision in its preparation. A single Cheeto begins with corn that has passed through at least 7 distinct quality checkpoints before it even reaches the mixing stage. These include initial farm selection, harvest quality verification, moisture testing, particle size analysis, contaminant screening, color evaluation, and nutritional composition analysis. This level of scrutiny explains why major manufacturers maintain strict contracts with specific farms that can consistently deliver corn, meeting their exact specifications. As the cornmeal awaits the next stage of production, It bears little resemblance to the bright orange snack it will become. The transformation about to occur would have been technologically impossible in Charles Doolin's original kitchen. The carefully prepared cornmeal will soon enter industrial extruders that subject it to extreme conditions. Temperatures between 100 to 200 degrees Celsius and pressures exceeding 150 psi. This radical environment will convert the simple cornmeal into the distinctive puffed structure that gives Cheetos their characteristic texture. The carefully prepared cornmeal now undergoes perhaps the most remarkable transformation in the entire Cheetos production process. The question that puzzles many consumers is how a dense, heavy cornmeal mixture becomes a light, airy snack in mere seconds. The science behind this transformation reveals the perfect marriage of physics, chemistry, and precision engineering. The process begins with the mixing of cornmeal and water in large industrial mixers. Operators add water to the cornmeal at precisely controlled rates to achieve a moisture content of approximately 15 to 17%. This exact moisture level is critical too dry, and the mixture won't expand properly. Too wet, and the finished product will be dense and chewy, rather than light and crispy. The mixing equipment incorporates water gradually while continuously monitoring the moisture content through sensors that provide real-time feedback to the control system. This moistened cornmeal mixture, now with a dough-like consistency, moves through conveyor systems into the heart of Cheetos production, the extruder. Modern food extruders are essentially industrial pressure cookers, combined with mechanical processors. These massive machines, often spanning 20 feet in length, create the extreme conditions necessary for the Cheetos transformation. Inside the extruder, the temperature ranges between 100 to 200 degrees Celsius, while pressure builds to approximately 300 pounds per square inch, conditions that would be impossible to replicate in home cooking. The extruder contains a giant screw mechanism that rotates within a sealed barrel. As the cornmeal mixture travels through this barrel, the rotating screw generates both mechanical energy and friction, which contributes to heating the mixture. The combination of heat, pressure, and mechanical energy transforms the cornmeal into a thick, almost liquid consistency at around 280 degrees Fahrenheit. This transformation occurs as the starch molecules in the corn gelatinize, creating a homogeneous mass. The now transformed mixture progresses to the final section of the extruder, where it encounters a specialized die. This die features specific openings that shape the mixture as it exits. The engineering of these dies is a closely guarded secret in the industry, with their exact specifications determining the final shape and expansion properties of the product. Some Cheetos production lines use dies with circular openings for tubular shapes, while others employ more complex geometries for twists and curls. What happens next is the key to Cheetos' distinctive texture. As the pressurized cornmeal mixture exits the die, it experiences a sudden drop in pressure from 300 psi inside the extruder to normal atmospheric pressure. This dramatic pressure change causes the water molecules in the mixture, which have remained liquid despite their high temperature due to the high pressure, to instantly flash into steam. The rapid expansion of water into steam creates countless tiny air pockets throughout the structure, similar to how popcorn pops but with much more precision and control. This expansion happens in a fraction of a second, with the product increasing in volume by 200 to 300%. High-speed cameras capturing this process show the cornmeal mixture erupting from the die openings and expanding almost explosively as it contacts the cooler, lower-pressure environment. Positioned immediately at the extruder exit are high-speed rotating blades that cut the continuously flowing expanded material into uniform pieces. These blades rotate at precisely calculated speeds, synchronized with the flow rate of the extruder, ensuring each piece is cut to a consistent length. The freshly extruded and cut pieces, known in the industry as colettes, bear little resemblance to the final Cheetos product. At this stage, they appear as pale yellow expanded structures with a texture similar to rice cakes. They contain approximately 8 to 10% moisture content and lack both the crunch and flavor associated with the finished product. The colettes have a soft, slightly spongy texture due to their internal structure of countless tiny air pockets separated by thin walls of gelatinized starch. The extrusion technology represents a revolution in snack food production. What once might have taken hours of baking and preparation can now be accomplished in seconds through a controlled scientific process. Each colette contains a microstructure optimized for the perfect crunch air cells of specific sizes surrounded by walls of precise thickness. This structure could never be achieved through traditional cooking methods and explains why the exact parameters of the extrusion process remain proprietary information closely guarded by manufacturers. The uncoated colettes now move via conveyor to the frying stage, where they'll develop the characteristic crunch that makes Cheetos so satisfying. During frying, the remaining moisture in the colettes evaporates, leaving behind the rigid cell structure that creates the distinctive crunch when bitten. This transformation from soft, pale colette to crunchy snack is the final structural change before the application of the famous orange cheese coating that gives Cheetos their signature flavor and appearance. The entire Cheetos production process takes just 19 minutes from cornmeal to packaged product. This efficiency represents one of the most technologically advanced food manufacturing systems in the world. Each bag of Cheetos contains pieces that have undergone precise temperature and pressure controls, ensuring consistent quality in every package. Charles Elmer Doolin, working in his small Texas kitchen in 1948, could never have envisioned the scale of modern Cheetos factories. Yet, the fundamental principle remains unchanged, transforming simple corn into an appealing snack through innovative technology. The next time you open a bag of Cheetos, you're experiencing the culmination of decades of food science and engineering innovation.